Hello everyone, welcome to our class. My name is Ko Chen Lee. In today's sections, we will talk about performance monitoring. This is today's outline. We will first start with introductions, then talk about tuning performance, memory usage, and data throughput. We will also show you how to track a system's general health and events and troubleshootings by using the event viewer. When you install a server, you should create a performance baseline to see how server is performing given its current resources and typical usage. If server isn't performing as expected, is unresponsive, or is generating errors, you will want to try to investigate. Many tools are designed to help you monitor server performance and troubleshoot performance issues. We will show you the key tools for fine-tuning the system configurations, tracking system health, and troubleshooting the event logs. Out of the box, Windows Server 2008 is optimized for general network environments. The operating system might not, however, be optimized for the way a particular system is being used in your organization. You can often improve Windows operating system and application performance considerably simply by fine-tuning the way a system uses resources. One of the reasons the Windows operating systems no longer shipped with 3D screensavers is that when these screensavers turn on, they use a considerable amount of processing power to render the 3D art. Similarly, you don't want the Windows operating system to tie up too much processing power displaying visual effects when administrators or other users are logged on to a server. All the fancy features are turned off in the standard configuration of Windows Server 2008. In most cases, it keeps the visual effects to the bare minimum as per the default configuration after installation. This ensures that users who log on either locally or remotely won't severely impact the performance of the system just by logging on and displaying menus and dialog boxes. And you can check or change the visual effects options by using the Performance Options dialog box, as shown in the screen. The way the Windows operating system performs for applications and installed services is determined by processor scheduling configurations. Processor scheduling options control how much processor resources are allocated to applications running on the server, which in turn determines the responsiveness of applications. And you can optimize processor scheduling for the following application types. Programs. When processor scheduling is optimized for programs, the active foreground applications running on the system gets the best response time and the greatest share of available resources. When processor scheduling is optimized for background services, all applications receive equal amounts of processor resources, and the active application doesn't get the best response time. And you can check or change processor scheduling configurations by using the Advanced tab of Performance Option dialog box, as shown in the following screen. And Windows Server 2008 uses virtual memory to allow a system page parts of memory to disk. This makes it possible for a system to create a paging file on disk and use more memory space than is physically available. All servers have an initial paging file. It is created automatically on the drive containing the operating system during installation and setup, and written as a file named pagefile.sys. And you can configure the size of the paging file so that it is optimal given the server's RAM and usage. And you can also fix the page file size so that the server needn't spend any resources expanding the page file. This helps to ensure that paging file doesn't become fragmented, which can result in poor system performance. If a server has multiple hard disk drives, you might consider creating a paging file for each physical hard drive on the system. And the fastest, easiest way to track a system's general health is to use Task Manager or Process Resource Monitors. Unlike some of the other performance tools, they require some preparations before you can use them. You can start and use these tools without any preparation. This makes them very useful when you want to see what's going on with the system right now. For monitoring essentials, by using Task Manager, you can track running applications and processes and determine resource usage. This can help you understand how a server is performing and whether there are any problems, such as applications that aren't running or processes that are hogging system resources. To work with Task Manager, the key issues you must understand is the distinction between an application, an image name, and a process. Task Manager has 6 tabs: Application Processes, Services Performance, Networking Users. No single command line tool performs all the same functions as Task Managers. The closest tools in functionality are the PowerShell CMD-LETs, Get Process and Get Service. You obtain detailed information about running processes using Get Process and detailed information about the config service using Get Service. The Performance tab in Task Manager shown in figures. It provides a summary of current processors and memory usage as well as some historical usage statistics based on data collected since you started Task Manager. The CPU usage and CPU usage history graphs shows the percentage of processor resources being used. In figure, the server has 2 CPUs, so there are 2 history graphs. The memory and the physical memory usage history graphs show the physical memory being used by the system. System shows summary statistics for handles, threads, processes, uptime, and page file usage. Processes shows the number of processes in use. Uptime shows you the total amount of time the system has been up since it was last started. Page file shows you the current size of the page files in megabytes, followed by the maximum possible size for the page file. The maximum page file size is determined by the virtual memory configuration of the server. Physical memory shows the total RAM on the systems. Total shows the amount of physical RAM. Cached shows the amount of memory used for system caching. And free shows the RAM not currently being used and available for use. Kernel memory shows the memory used by the operating system kernel. Total lists all memories being used by the operating system kernel, including physical memory, RAM, and virtual memory. Non-paged reflects memory used by the operating system kernel that can be returned to disk. Paged reflects memory that can be paged to virtual memory if necessary. Sometimes the CPU usage can be high if the system has too little memory as well. Figure shows performance data for the same system. In this example, the system has high CPU usage, and in many cases, CPU usage is at 100%. If CPU usage were consistent at 100%, I might suspend a runaway process and look for a process that is causing the problem. Here, increasing the server's RAM or virtual memory will not solve the problem. If the high CPU usage activities are related to install applications, roles, or the role services, you might want to consider adding CPUs to the server. Generally, you add CPUs to a server in matched pairs. In this example, the server has 2 CPUs, so you will want to consider upgrading to 4 CPUs. You might also consider offloading some of the system load. For example, you can move one of its roles or applications to a different server. And getting information on running applications. The Applications tab in Task Manager showing figure lists the applications being run by users on the computer along with status details that shows whether the applications are running or not responding. You can view information about processes running on a system by using Processes tab of Task Managers or by running Get Process. The Task Manager display differs greatly from the output provided by Get Process. The interactive user is the user account logged onto the local console. If you don't want to see processes from remote users, such as those users connecting by using remote desktop connection, clear the Show Processes from All Users checkbox. The CPU column shows the percentage of processors utilizations for each process. And the memory column shows the amount of memory the process is currently using. At the Windows PowerShell prompt, you can get key states for all processes and some interesting additional properties you can use with Get Process. In Task Manager, you can stop processes that you suspend on running properly. And you can view information about services running on a system by using the Services tab of Task Managers, or by running Get Service, as shown in figure. Services are listed by name, process ID, PID, description, status, and group. As multiple services typically run under the same process ID, you can quickly sort services by their associated process ID by clicking the related column heading. At the Windows PowerShell prompt, you can get the status of configured services simply by entering Get Services. By default, only the service status, internal name, and display name are shown. Additional properties that you can display include can close and continue, can stop dependent services, services depend on, and you can use the following commandlets to manage your services: suspend services resume, service start service stop, service restart service. Typically, you will use a restart service when you suspend a service is having a problem and you want to reset it. As figure shows, the Networking tab in Task Manager displays current network usage for each of the system's connections to the network. You can use the information provided to determine the following quickly: the number of network adapters installed on the computers, the percentage of utilization for each network adapter, the link speeds of each network adapter, and the state of each network adapter. And members of the administrator group and any users to which you specifically grant remote access can connect to systems using terminal services or remote desktop connections. And you can enable the remote access feature by using the System Utility in Control Panel, System and Maintenance. With Remote Desktop, Windows Server 2008 allows 1 console sections and 2 remote administration sections. Most remote sections are created as console sections. The reason for this is that the console section provides full functionalities for administration. To keep track of sections after you have configured terminal services, you can use the User tab of Task Manager. And understanding the event logs. The system services that controls event logging is the event log service. When this service is started, events are recorded in one of the available event logs. 2 general types of log files are used. Windows log. Logs that the operating system uses to record general system events related to applications, security, setup, and system components. Applications and services logs. Logs that specific applications and services used to record application-specific or service-specific events. And Windows log you will see includes applications, contains event logged by applications, and forward events. When you configure event forwarding, This log records forward events from the other servers. And security contains events you have set for auditing with local or global group policies. And setup. And this log records events logged by the operating system or its components during setup and installation. Systems contains event logged by Windows Server 2008 and its components. And you should routinely check this log for warnings and errors, especially those related to the failure of a service to start at boot up or the improper configuration of a service. And applications and services logs you will see include DFS replications. This log records the distributed file systems DFS replication activities. Directory service contains events logged by Active Directory. DNS server contains domain name system DNS queries, responses, and other DNS activities. And file replication service contains events logged by the file replication service, a service used to replicate Active Directory changes to other domain controllers. And hardware events. When the hardware event subsystem event reporting is configured, this log records hardware events reported to the operating systems. And Microsoft Windows. Logs that track events related to specific Windows services and features. And you can view the event logs using Event Viewer, as shown in figures. Event Viewer has custom views as well as standard views of logs. Using the custom administrative event view, and you can view all errors and warnings for all logs. And figure shows individual events entries provide an overview of the events that took place. Each event is recorded according to the date and time the event took place as well as the event label. For all the logs except security, the event labels are classified as information, warnings, or error information, generally related to a successful actions, such as the success of a service starting up. A warning describes events that aren't critical, but could be useful in preventing future system problems. Errors indicates a fatal errors or significant problem occurred, such as the failure of a service to start. And you can use Event Viewer to view events on other computers on your network, sorting, finding, and filtering events. Event Viewers provide several ways for you to organize and search for events in the logs. You can sort events based on date or other sorted information. And you can search a particular event log for specific events and view events one at a time. And you can also filter events so that only the specific events you want to see are shown. In most cases, you will want to have several months' worth of log data available in case you must go back through the logs to troubleshoot a problem. So, as part of your routines, you might want to archive the log files on critical systems periodically. such as for domain controllers or application servers. When you are working with a specific system or trying to track down issues, Event Viewers is an excellent tool to use and should be your tool of choice. As you have seen, Event Viewers can also be used to access logs on remote systems. And you can use getEventLog to obtain detailed information from the event logs. And because getEventLog is a text-based rather than graphically utility, it will, in most cases, use fewer system resources than Event Viewer. In an enterprise, you might also want servers to forward specific events to central event login server. And to do this, you configure and enable event forwardings on the applicable servers. And then you create subscriptions to the forwarded events on your central event login servers or servers. In the domains, you can configure forwarding and collections of forwarded events by following these steps. First, to configure forwarding logs onto all source computers and type WIMRM quick config at an elevated command prompt. And second, to configure collections, type WECUTIL QC at an elevated command prompt. Add the computer account of the collector computer to the local administrators group on each of the source computers.